Hello, everybody. Today I will be going over how to create the equation of a plane if we're giving three coordinate points. So we always need three usually. Um, so the first thing we want to do is we want to create two vectors because when we have two vectors like this, for example, you can see that this shape comes up. So this is a plane. A plane can come from this if you have 3 points. So let's first make the vector. So let's do P to Q. So terminal minus initial. So that'll be 5. That'll be 8. And that'll be -2. Okay, now P to R. Okay, so P to R, -1, 4. So -3 minus 5, -8. Okay, so now that we have it, we can. And now the next step is because now we have two vectors, right? Now we want to create another vector that's orthogonal to both of the vectors. So if we create a vector that's orthogonal to both of the vectors, it's gonna look kind of like this. And if we create a vector that's orthogonal to both of the vectors, it's gonna have this vector is gonna kind of give the direction of both of those vectors. So aka is giving us our slope if we create this normal vector. So how do we create a normal vector? We do the cross product. So we do P to Q is cross with P to R. So it should be 5, 8. Let's do I, J, K. 5, 8, -2. And then -1, 4, -8. Okay, so this would be -64. This would be +8. This would be the I minus. So that would be -40. And then -2. That would be J plus 20 minus plus, because that becomes a positive, 8. That's K. Okay, so now we have -56 I become -42, and then so plus 42J plus 28K. Okay, so now that's our normal vector, and I like it in this format better instead of the IJK. So -54, 42, 28. Okay, so now that we have this, we have our slope, correct? So now what we can do is take this vector and dot it. So sorry. So it should be this should be the general format. So n dot x y z is equal to n dot, and the n is a vector, and this is our n. So n stands for the normal vector, aka the orthogonal vector, times our x initial, y initial, and z initial. Okay, so the reason why we dotted it, we want to make kind of like a scalar of it, because this equation is technically a scalar instead of a vector. So we have our n, right? So our n is this. All we do is dot it with it. So all we do with the dot product, multiply. So negative 54 times x is just negative 54x, then plus, 42y plus 28z. And now all we gotta do is say that's equal to, so what's x initial? So I can use p. P was our initial. That's why I use initial for both of our points, so let's use p. So technically this thing is being dotted with 0, 1, 5. So we can say that's this times this is 0, then 42 times 1 is 42, then 28 times 5 is 140 plus 140. So now we get to add it, so it's 182. And that's the equation of a plane. So to summarize, we create a vector, two vectors, we create a normal to figure out the slope of it, and then we figure out the initial value. This is the general form of an equation of a plane. And we can always set it equal to z. Okay, so now that we have that, I want to talk another thing about planes. So what happens if two planes are in the XYZ axis, and then what happens if they intersect, right? I want to find the equation of the line of the intersecting planes. So let's say I have a plane of x plus y is equal, should be x plus y plus 5z is equal to 5. And then I have another plane that's negative x minus 2y plus 3z equals 3. So first of all, I want to see if they're actually going to intersect, and where are they going to intersect. So what I need to do is I need to do a system of equations to figure that out. So what happens if we say z is equal to 0, right? Z is equal to 0, and if z is equal to 0, both the z's goes away, and then you have x plus y equals to 5 for this one, and then I can just bring this one down to make it easier to write as a system of equation. Minus x minus 2y is equal to 3, right? So now we can do elimination, so we can add them. So these two go away, which work perfectly, and then this will be a negative y, and then this will be an 8. So now this will be y is equal to -8. And then now we can plug this -8 into one of the equations here. We can plug it into x minus 8 equals 5. And then we can say that's 13. X equals 13. So that's where they intersect. It's not technically where they intersect because it's a plane. They're gonna intersect because it's a plane. They're gonna intersect as a line equation. But we found a point on where they intersect. So I can rewrite this point as maybe as a vector, and if I write as a vector, that's gonna help us. So I can say 13, -8, and then 0, 0. Okay, so that's good. So now all we have to do is to find where it intersects. We gotta take the cross product of these two of the two planes. So let's say this plane is here. Oops. This is gonna be hard to draw. And then the other plane is intersecting it. It's kind of crossing it right this. So if I take the cross product of both of them, I'm gonna kind of have. Okay, so it's the best way to think about it. Why am I taking the cross product? Okay, so if I take the cross product of these two vectors, right? So this n, right? The n of this one. So let's call this. Let's take this as red. So this is plane 1. This is plane. Yeah, this is plane 2. Okay. And this is plane 2. So if I take the normal of this, so the normal of this, how we did it before, the normal is just pretty much the slope of it. So 1, 1, 5. This is 4 and 1, and then the other normal is -1, -2, 3, and this is n2. So this is gonna create this, then this is gonna create this, and if I do the cross product, it's gonna create another vector that's orthogonal to both of them in this direction, or it can be in the other direction, and that direction and that's the slope of the line. Okay, so now that that's out of the way, we can compute the cross product. So 1, 1, 5, and then -1, -2, 3, and then we can do it. So 3 minus plus 10, that's I, minus, so that's 3 plus 5, J, plus -2, minus those, and then that's plus 1. That's K. Okay, so that's 13i minus 8j minus k. Okay, so now that we did this, we can actually let's make it into this form because that's better. I like that form better. -8 and then -1. So this line we can write it as a vector. So because this is the slope of it, we can just say this is t. So t is just the variable, and then plus a point in the plane that is intersect. So we can take this form. Is equal to 13 -8. Oh, that's supposed to be a negative, and then 0. And then that's equal to the x, y, z. And so that's the equation of the line in a vector form. And you could always turn this into a parametric form, but I'm gonna leave it as is. Well, overall, so that was kind of a wrap about the introductory part of what vectors are. Now we're gonna go into how to take derivatives and how to integrate, how to take limits of vectors. Thank you.